Hello students, welcome once again. Now in the list of predictor paper, this is going to be our third predictor paper, and that is for the last 2 days, 28 and 29. Okay, so this paper, as we will move ahead, you will find that this is a bit on the difficult side. That's my assumption, that's my prediction for the last 2 days. Okay, now by now I think most of you would have analyzed the paper. So my analysis says that the second shift was a bit more tricky, and then third day first shift was again a bit more tricky and a bit more lengthy, I believe. Okay, so again I will say, I will suggest you all, because still you people have time. Okay, so when you are practicing the question, so you just go through this paper, try to solve this question, and then of course since I am giving you with a solution also, then you can go through the solution. Answer doesn't matter at this moment. Okay, so the practice means you should know how to approach the question. If you know that okay, that can be easily done, if you can analyze the question like the question which we have in front of us, so if you can quickly analyze it and you can see that okay, this is how we are going to simplify it, and this is what are we going to get at last, and then answer doesn't matter. Okay, so now let's start. Okay, so the first question here is in the expansion of this multinomial, I will say, of course, the constant term is, so we have to find the constant term, that means the term which is independent of x. Okay, now why did I give you this question? Because see, it needs a bit of manipulation, okay, and observation, use of your previous small classes identity. So if you look at it carefully, isn't this x raised power 1 by 3 plus 2 whole square? That's first thing. Whole square raised power 5 is 10 here. Now when you take LCM, bachcho, when you take LCM, so what do you get? You get x raised power 2 by 3 plus 2 times x raised power 1 by 3 plus 1, and 1 minus 1 gets cancelled, and in the denominator, aren't they like two factors of the identity a cube minus b cube? Answer is yes, this is a minus b, a square plus ab plus b square. Okay, so this is nothing but a cube, so x raised power 1 by 3 whole cube is x minus b cube, of course 1 raised power anything is 1 itself. Now this is minus 9, so let's simplify it. So x raised power 1 by 3 plus 2 times whole raised power 10, and here if I take let us take the reciprocal, of course the power is minus 9, and then if we take x raised power 1 by 3 common here, okay, so it's actually whole raised power 9, and then you have x raised power 1 by 3 plus 2. See, that's what I meant when I said that okay, if we can see that to what extent can we simplify it. So this is x cube now, so it's x raised power 1 by 3 plus 2 upon x cube, and then x minus 1 whole raised power 9. I'm sorry, I missed that. That's it. Now which term is independent of x? See, the power. So if I break it into two parts, so it's nothing but 1 by 3. See, you won't have any fractional power in its expansion for sure. So the only possibility of getting the term independent of x is when you multiply this term 2 by x cube, because 1 is, then x raised power 1 by 3 upon x cube. Now multiply this term with what? With x cube in this expansion. So when you expand it and get x cube, multiply this term, so 2 times 9c3 should be the answer here. Okay, so 2 times 9c3 or 9c6, whatever you call it, so that should be the answer, because you need x raised power 3 in its expansion, which then when multiplied by 2 by x cube gives you the term which is independent of x here. So that's the first question. So not a tough question, of course, but look at the format of the question. You would have found such type of question already in your one or the other shift, where the format is quite difficult, tricky, complex looking. Okay, but when you simplify it using the basic steps or basic things, you will be able to simplify and solve it. But okay, so that's your first question here. Moving to the next question. Next question is limit as n approaches infinity, n square plus 2 into n minus 1 whole square plus 3 into n minus 2 whole square, n times 1 square divided by 1 cube plus 2 cube plus dot 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 n cube. So that's it. Now see, the purpose of picking up this question is to take a few questions, and I have already selected few more questions on series part of it. Okay, so the series part. So in denominator, whenever we have to solve such a series or simplify it, of course we need to write the general term and then use formula. So here it's sum of cube of first and natural number. So if you remember, or I shall write it somewhere, bachcho, we should remember that summation r cube when r goes from 1 to n is nothing but n into n plus 1 by 2 whole square. So that's what I'll be writing here. So denominator is for sure n into n plus 1, so whole square by 4 here. That's it. But what about numerator? See, for numerator I will suggest you to write the general term. Okay, so it's 1 into 2, 1, 2, 3, 4. So r times. Now it's n square. N square means n minus 0 square. This is second term, n minus 1 square. So other term will be n minus r minus 1. Isn't that? And it's square. So r goes from 1 to n here. Okay, so r goes from 1 to n, of course. So that's what you will get here. Now, of course, the denominator is already done. We need to simplify the numerator. So for that, we will be using some properties of summation, which says that summation get distributed over addition or subtraction. So for that, again you need to simplify it. So it's n plus 1 minus r, plus 1 minus r whole square. So I'm not writing this again and again. So for from here, take from denominator, take it to the numerator. Okay, so now this is r into n plus 1 whole square. So that's a constant with respect to r, and then plus r square, so plus r cube, and then minus 2r, so minus 2r square into n plus 1. So now that's it. So what we can write, so upon something in the denominator, so what can we write here? So it's limit n tends to infinity 4 times, and in the denominator we know n square into n plus 1 whole square. Now in numerator we have n plus 1 whole square, summation of r, first step. Second one is plus r cube, so it's not, we already know summation r cube, what is it? We have already seen it. And then we have minus 2 times minus 2 times n plus 1 common, and that is summation r square. Now just to write it, summation r is what is it? So n into n plus 1 by 2 when r goes from 1 to n. What is summation r square? Summation r square is n into n plus 1. So I'm just writing it for the reference, bachcho. Okay, so that if you don't remember it, so from here onward you shouldn't forget it. Okay, now one very important thing, it's a question of limit. A very important aspect is, of course, it's going to be infinity by infinity form, because n approaches infinity. So both numerator and denominator is infinity. Now in infinity by infinity form, and in both numerator and denominator, if you have polynomial form, which is the case here, in denominator it's a degree polynomial of degree 4. In numerator it will be a polynomial of degree 4 for sure. Okay, now so if you have same degree in both numerator and denominator, then the answer is the ratio of leading coefficient of numerator and denominator. So you have to just collect the terms of n raised to the power 4 in the numerator. In the denominator, the power the coefficient of n raised to the power 4 is just 1. So you have to just calculate the leading coefficient of n raised to the power 4 in the numerator. And then again I am repeating, if the form is infinity by infinity and it's a polynomial in both numerator and denominator, then and if the degree of both numerator and denominator match, then the answer is direct, and it is the ratio of leading coefficient of numerator and leading coefficient of denominator. So now you can simplify and get the answer here. I think answers are marked or not, let me just check it. No, they are not. Okay, it doesn't matter. If pens of a particular brand are all identical, one thing, and the number of ways in which we can choose 6 pens out of 8 different brands. Number of ways of picking up 6 pens out of 8 different brands. Okay, now what does that mean? See, you have 8 different brands. So brand 1, brand 2, brand 3, similarly brand 8. You have to select 6 pens from 8 different brands. Okay, now what does that mean? See, there is no restriction whatsoever that how many pencils or pen you can have from a particular brand. And of course, there will be 2 brands from where you are definitely not going to choose any pen. Okay, so that means simply means there is no restriction whatsoever. Okay, now what we will say? See, we'll say let us select from here x1 number of pens, x2 number of pens, x3 number of pens, since pens of same brand are all identical. Now what matters here is that the sum of this number should be 6, isn't that, bachcho? Since, again I am repeating, since the pens are identical, so it doesn't matter which pen has been selected from brand 1, they are all identical. What matter is how many pens are selected from brand 1, how many pens are selected from brand 2, and so on and so on. Okay, so it's just similar to the case when you have identical balls and you have to put it in distinct boxes. In how many ways you can do it? Okay, so it's just the similar case here. So let's say there are 8 distinct boxes and you have 6 identical balls, in how many ways you can do it? In how many ways you can do it? You will say, okay, you can put x1 balls in first box, x2 balls in second box, and similarly x8 balls in 8 balls. Add them and the sum has to be 6 without any restriction. So what are we actually looking for here? We are looking for its non-negative integral solutions. So we are looking for its non-negative integral solution. Now what's the formula? So I think we have already discussed it somewhere, but again I am writing it. So if that's the case and we are looking for non-negative integral solution, number of solutions are n plus r minus 1 c r minus 1. Okay, so here r is 8, n is 6, so 6 plus 8 minus 1 13 and 7, 13c7 or 13c6 is the same thing. So the answer is 13c6 here. Really important concept, really important question here, bachcho. Okay, moving to the next one. Numbers 1, 2, 3, 4, 2n are printed on 2n cards. The probability of drawing a number is proportional to r. Okay, so this should be r. A number r is proportional to r. What does that mean? That probability of getting this is like p times r, where p is proportionality constant. Then the probability of drawing an even number in one draw is. Okay, now what? See, we know that probability of drawing card 1 or card 2 still so on and so on 2n has to be 1, because when you are going to draw a card you are going to get any one of these numbers, so of course the sum of the probability has to be 1. But what do we know from here? So we know that p plus 2 into p plus 3 into p plus dot 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 p into 2n is equal to 1. So why am I doing it? Because of course we need p, then only we have the probability of selecting any number out of these 2n numbers, isn't that? So it's like p common, so sum of 2n natural numbers, and the formula is 2n into 2n plus 1 by 2, and this is equal to 1. So p is 2 upon 2n into 2n plus 1. So I can write it as p is 1 upon n into 2n plus 1. That's our p. Now let's see what do we need. The probability of drawing an even number. So even number can be 2, 4, 6, 8. So what do we need? Either it will be 2 or, since they are all mutually exclusive events, like selecting number 2 or number 4 aren't they mutually exclusive? Because we have only one draw. So either you will get 2 or you will get 4. So if they are mutually exclusive, either or leads to sum of probabilities. I am repeating, if the events are mutually exclusive, either or lead us to sum of probability, bachcho. Okay, so p of 2 will be 2p. Okay, so p again common, 2 plus 4 plus 6 and so on till 2n. So again 2 common, so 2p, and this is 1 plus 2 sum of n natural number. That's what we need, and this is 2p into n plus 1 by 2. 2 gets cancelled, so n into n plus 1 by n into 2n plus 1. So is that the an option? Let us quickly check it. That should be the answer. So n plus 1 upon 2n plus 1. So D option should be the correct option here, bachcho. Okay, so that's your next question. Moving to the next one here. Next one is phi x is this function. Okay, phi x is integral of 1 by ln t with respect to t when t goes from x square to x cube, where x is greater than 0. Okay, then we have to find that phi x is minimum at x is equal to 1, maximum at x is equal to 1, is neither maximum nor minimum, or is an increasing function for all positive x. Okay, because x is already given to be greater than 0. See, for increasing or decreasing, or for maxima minima, we know the first step is differentiation, and here what are we going to use? We are going to use Leibniz rule of differentiation. So what is it? It says that that's the function, let's say, then phi dash x, derivative of such a definite integral where the limits are a function of some variable. Of course, we will be differentiating with respect to that variable only. So here the limits are function of x, so we can differentiate with respect to x. So phi dash x is f of the integrand. Replace the input of the variable of integral t by the upper limit, so f of h of x into its derivative s dash x minus f of g of x, the lower limit, into its derivative g dash x. And that's the way of using Leibniz form. If see, that will be important for advanced level question. We have already solved few very good questions in if you go to the playlist of definite integration for that JEE Excel or TEJAS series. Okay, so there you will find that we have used it 2-3 times the exact form of Leibniz rule. But then for mains we will be restricting ourselves to this one only. That I think that much should be sufficient. So now writing phi dash x. So what is it? So 1 by ln of upper limit into derivative of x cube, which is 3x square, minus 1 by ln of lower limit into derivative of x square, which is 2x. So see, the framing of this question is such a well framed question this is, isn't that? Because ln x cube is 3 ln x, 3 will get cancelled, x square by ln x, minus 2 gets cancelled, x by ln x. So isn't that x into x minus 1 by ln x, since x is positive? So therefore phi dash x, we know the critical points are the points where either the derivative is 0 or where derivative is not defined. So there is no case where the derivative is undefined, of course, except at x is equal to 1, because at x is equal to 1 ln x will be 0. Okay, that's a problem. So how are they saying that phi dash x is okay? Then again, of course, sorry, ln x is 0, that means at x is equal to 1 derivative is not defined, so that's a critical point. Okay, so the critical point here is x is equal to 0 can't be the case because x is already greater than 0. So x is equal to 1 is the only critical point here, bachcho. Now see, how will we say that whether we have a maxima or minima, maximum or minimum at x is equal to 1? Now what we can do here is we can go for the sign change, sign change of f dash x or phi dash x, which is x into x minus 1 upon ln x. Okay, now on the left side of 1, when x is less than 1, of course this is positive, so positive. This is negative because let's say x is 0.9 minus 1 is negative, and ln x is also negative when x is less than 1. So this is negative, so negative makes it positive. So overall this is greater than 0. Okay, now on the right side of 1, the sign of derivative, so I'll go again, this is positive, of course this is positive, and this is positive, then that's it. So this is again positive. So is there a sign change about the critical point? Answer is no. So since there is no sign change, of phi dash x, this implies neither maxima nor minima. First thing, neither maxima nor minima at x is equal to 1. But very important thing is that phi dash x is throughout positive. In that case, phi dash x is always positive, so greater than 0 on both the sides. So doesn't that mean this implies no sign change? And since phi dash x is greater than 0 for all x greater than 0, see, there you might have a problem at x is equal to 1. So at x is equal to 1, again you can go for the limiting value, bacho, x minus 1 upon x, so it will be approaching 0. So in no case it's negative. So phi dash x is positive, so this implies phi dash x rather phi x is an increasing function. So that's again one of the interpretation. So either you can say phi x has no maxima, no minima at x is equal to 1, or it is always an increasing function. So let's look at it. Phi x is an increasing function, that's true, is neither maximum nor minimum, but is an increasing but an increasing function for us. So C, I think, no, that depends what is the statement here. If it's there that but it's not an increasing function, so answer should be D. Otherwise answer should be C here. So I don't think I have marked the answer. So there might be some typing error here, bacho. According to me, in that case, phi x is an increasing function for all x belonging to R. Okay, for all positive x. So that's it. So that question was on Leibniz rule. Moving to the next question here. See, you would have found such type of question. Okay, in your JEE previous this year. I mean just 1 or 2 days back, JEE shift. Where see, I just told my students that see the biggest hint in that question was, if I remember it. Let me just try to recall it. There was something ln only. Yeah, e square to e raised power 4. Yes, the question was e square, integral from e square to e raised power 4, e raised to the power, the integrand 1 upon 1 plus ln x whole square, and something in the denominator. We use Bahubali property to solve it. So there again I said the biggest hint was presence of x along with dx in the denominator. Here in this question also the biggest hint, without thinking anything else, you should know that you have to replace ln x by t. Why? Because you get it as a ready-made thing, dx by x to be replaced by dt here, bacho. So your integral is, so it's from 1 to 7122, isn't that, bacho? So it's nothing but 1 plus 1 minus t upon t into ln x minus ln of ln x, so t minus ln t, and that's it. Okay, so I think we are done. Yeah, we are done. So we can write it as 1 to 7122, so 1 is dt plus 1 to 7122 integral, and then if I take t to the numerator, so it's 1 by t minus 1, and then t minus ln t dt. Now we are done. The derivative of denominator is sitting in the numerator with opposite sign, so I can definitely change the sign. Do I need it? Was it positive or negative? It's positive, so we can change the sign here. So positive and then it's negative, then we can easily solve it. Okay, so that question again, the purpose was to get you a similar question, okay, in different format here. So again, an interesting and good question. Now moving to the next question here, if x lie between 0 to pi by 2 and y is, so y is e raised to the power sine square x plus sine raised to the power 4x plus till infinity times ln 2, that's your y. So isn't that e raised to the power ln 2 into, isn't that infinite gp? So first term is sine square x, and common ratio is again sine square x, so 1 minus r sine square x, which is cos square x. So e raised to the power ln 2 into tan square x, so I can write it as e raised to the power ln of 2 raised to the power tan square x. I think all of you will agree, and we know from property a raised to the power log x to the base a, or t here is t. So this is nothing but e raised to the power log t to the base e. So this is nothing but 2 raised to the power tan square x. So why is this? Okay, is a root of this quadratic equation. So this is nothing but x is equal to 8 or x is equal to 1. That's the root of this quadratic equation. To 2 raised to the power tan square x, then the value of this is, okay, so x lie between, say, so what are the possibility? 2 raised to the power tan square x is 1, and then 2 raised to the power tan square x is 8 here. So for this to be 1, of course tan square x has to be 0, and since x can't be 0, tan 0 is 0, isn't that? And x is in the first quadrant, so between 0 to pi by 2 x can't be 0, so that means that's not a possibility. So here tan square x is nothing but 3, because we can write it as 2 cube 3, so tan x is root 3, it can't be again minus root 3 because x is in the first quadrant. So x is nothing but pi by 3, and then you can put the value, and get this answer here, bachcho. So that's it. So moving to the next question. Next is, if f is a differentiable function for all real x, f dash x is less than equal to 5. For all real x, f of 2 is 0, f of 5 is 15, then f of 3 is, okay. See, I got this question as a doubt, okay. Now, how did I approach it? How did I approach it? F of 2 is 0, so this is 2 comma 0. F of 5 is 15. So let's say this is somewhere 5 and this is 15. So 5 comma 15. Now if I join this line, let's say this is point A, this is point B, and I went for its slope. Why? Because see, f dash x represents slope of the curve only, isn't that? So if I go for its slope, then slope is 15 minus 0, y2 minus y1 upon x2 minus x1. So that's your 5. So slope of the chord joining C. Now the curve can be anything like this, it can be anything like this, or you can say, of course, it can have several many terms like this, or it can have several many terms like this, or even it can be something like this. The point is, the chord joining A and B has a slope of 5, and we are given that for all x belonging to R, the slope of the function is less than or equal to 5. Now, if I use here, see, that's why I decided to pick up this question, because here, the way I solved it, I used Lagrange's mean value theorem, LMVT. Okay, now I will definitely ask you people, if anyone has a better idea or any other idea, do share me with the help of in the comment here in the comment box. So I said we know from LMVT f of b, if I apply it over the interval a to b, isn't that? So the statement says, if function fx is continuous differentiable in the interval a to b, then fb minus fa upon b minus a will be equal to f dash of c for some c, at least one c in the interval a to b. Yes or no? Okay, so now what does that mean if I apply it for the interval 2 to 5? So what is it? It says that this is of course this is 5 and this is equal to f dash c. So derivative, the value of the derivative at c will be 5 for some c belonging to the interval 2 to 5. I think I am clear to everyone. Okay, now if it's a, see, it has to be a smooth curve, bachcho. It has to be a smooth curve because it is a differentiable function. So a smooth curve having derivative at some point c, so that means if it has any other derivative, try to understand, if it has any other derivative, then the transition has to be smooth. What I am trying to say is that if at some point the derivative is 5, then on the left and on the right of it, the sign of that derivative should be different. That there has to be some transition from smaller side of 5 to 5 and then moving to this larger side, or from larger side of 5 to 5 and then moving to its smaller side. But what are we given? We are given that f dash x is less than equal to 5 for all x belonging to the interval, whatever interval you consider, because for all belonging to R. Now what does that mean? That simply means that if it achieves 5, it's what the statement trying to tell us is that if it achieves the value 5, it can't move to the other side of it, or if it is coming to 5 and then all of a sudden it gets started reducing it, and since it's throughout a differentiable function, it's a smooth curve. So my interpretation is, then in that case I said that actually the derivative will be 5 only. It has to be 5 only for all x in the interval, and since it's 5, so fx is nothing but 5x plus 2, and then 5x plus c, and then you put x is equal to 2 here, so c is 0, so whatever, I mean f of 2 is 0, so 2 is 10 plus c is minus 1, so fx is 5x minus 1, that's it. So put x is equal to 3 and we get 5, so answer is 5 here. So that's what I got here, bachcho. That's how I approach this question. Okay, so there might be different ideas here, so if anyone having any other idea, let me know, definitely let me know. Let P be a point on this parabola that is nearest to the point A 0, 4. Now that's a vertical parabola here, standard vertical parabola. Okay, so any point, so let P be the point. We know in the parametric form it's extremely useful form for the standard parabola. Okay, we don't use parametric form so commonly in ellipse and hyperbola, particularly myself. I will talk about myself here, but in parabola I will say it's really an important one. So for y square is equal to 4ax, if I have to assume a point in parameter form, what do we do with you? We take it as 80 square comma 280. But for x square is equal to 4ay, what do we do? So we reverse the equation, isn't it? So it's 280 comma 80 square, है ना? So how much is a? You compare it, a is 1. So the point is 2t comma t square, and that's it. And the point is 0 comma 4. So maybe here it is somewhere, because focus is 0 comma 1. So here it is somewhere 0 comma 4. So you have to find this smallest shortest distance. So just use distance formula. So d is nothing, so under root. So I will write d square, because when d is minimum, d square will be minimum since it's positive. Okay, so it's x2 minus x1 whole square, 4t square plus t square minus 4 whole square, and then differentiate it. Okay, so that's our capital D. So d of capital D by dt and equal to 0, you get t, put the value, you have the point. Okay, so moving to the next question. See, I didn't use normal or anything else here. Now for me that's a really important form. Method of substitution is extremely important. One question we have already seen in one of our last few days JEE main shift. So that doesn't mean I'm giving you the similar question. No, it's a different question, but then method is same. Okay, so what was that question? First, if I come to it, if I remember it correctly, again, power I think I remember correctly, numbers I'm not so sure, so something like that. So the interesting thing or the form here is, if the sum of these two factors, the power of these two factors, their sum is 2. If the sum is 2, okay, then what do? We just divide one by other. So like I will write it as this, and then of course you divided it by x plus 2 raised by 11 by 13, you need to multiply it, and once you multiply it, it gets squared. Now we replace this by t. So that was the form, again a very important form, and we call it method of substitution, because we substitute a function by a variable t such that its derivative along with dx gives us dt. Okay, so the same is the thing here. Now the interesting part here is, or what I always try in such question is, take something common from denominator, such that when you take that common like factor from the denominator to the numerator becomes the derivative of denominator. So that's what I try. So I took from here x raised power 7 as it is. So you got here x raised power 4 out of this bracket. So it's 1 upon x raised power 5 plus 1 upon x raised power 7 plus 2 whole square. Now as I said, now take this the common factor from the denominator to the numerator. So what do we get? 5 upon x raised power 6 plus 7 upon x raised power 8, and that's it. So 1 upon x raised power 5 plus 1 upon x raised power 7 plus 2 whole square. Now I think all of you got it. If I replace it by t, okay, then dt is what? So minus 5 upon x raised power 6 minus 7 upon x raised power 8, and minus if I take common, dx. So that's it. So that's your minus dt. So minus dt upon t square. So the integral is 1 by t. So whatever you get it, and then you need f of 0, whatever. You can put the value, replace x by 0, you get your indefinite integral constant, get the value, do it. Okay. Now moving to next question here. There's a matrix which is AK 0 0 BK. Now what is AK? AK is k times 7ck, and B subscript k is 7 minus k times 7ck. Okay, now what do we need? Okay, we need sum of all these matrices. Okay, so first try to write it. So summation of AK when k goes from 0 to 7. Okay, so what will that be? Of course, A0 0 0 B0, A1 0 0 B1, A7 0 0 B7. So we know when we are adding the matrices, the corresponding elements add up. So A0, so it's nothing but summation AK, k goes from 0 to 7, 0 0, summation BK, k goes from 0 to 7. Okay, now see बच्चों, summation ak, which is summation k times 7ck, k goes from 0 to 7. If I call it as S, now applying Bahubali property, see, we can apply Bahubali property over summation also, like in integration. So what it says if we replace, and particularly when k starts from 0, okay, so 0 to 7, it says that if I replace k by sum of the limits, so 7 plus 0 is 7 minus k, so the value remains same bachcho. And we know, see, we know 7 minus k is same as 7ck, so this is same as S. Okay, so what does that mean? AK and BK are both same. Now the question is then the value of A plus B. Now what is A? A0 0 B. So A is summation of AK and B is summation of BK, and they are same. Let's say they are P, so it's 2P by 7. I think that's what they have asked, by 7. Now how much is it? So again, you need to remember this result here bachcho, R into NCR. When R goes from 0 to n, or of course 1 to n won't make any difference because R is equal to 0 gives it 0. So either R starts from 1 goes to n, or it starts from 0 and goes to n, won't make any difference here. Okay, now what's the result? So the result is, if I'm not wrong, n into 2 raised to the power n NCR minus 1, no? So this one, right? So the answer should be, so 2 into what was that, 7 into 2 raised to the power 6 by 7, so that's gone. 2 raised to the power 7 should be the answer. So 2 raised to the power 7 is 128, of course, right? That's it, isn't that? So that's it, yeah. So again, that was an important good question. Now boundary value problem, that's your boundary value problem. Sine inverse of lambda, sine inverse of mu, sine inverse of delta is 3 pi by 2, and we know the range of sine inverse x is not more than pi by 2 and not lesser than minus pi by 2. Of course, when all the three terms of sine inverse take their maximum value, then only they can add up to give 3 pi by 2. So that simply means that sine inverse of lambda is equal to sine inverse of mu is equal to sine inverse of delta, and they are all pi by 2 here. So when sine inverse gives us value pi by 2 at 1, okay, so delta is equal to mu is equal to lambda is equal to 1, so that's one thing. So they are all 1, so whatever value, doesn't matter. So it's 3 minus 3 times, they are all 1, no? So how come does that matter? I mean, delta raised to the power phi 2 into the 1 into 1 into 1, so it's 1 upon 3, so it's 2. I don't think we need, I mean, I would have thought something else. At that time I wouldn't have observed that we don't need anything else. Otherwise, see, two things because of which I gave this question. One was this and another one was this one. Okay, phi of x plus y. So still the purpose was to discuss few things related to such type of statements. Okay, and requirement in the question. First thing, looking at this one, we can claim this is nothing but an exponential function. That's the characteristic property of exponential function. A raised to power x plus y is a raised to power x into a raised to power y. Okay, that's what we are given. But then are we in the position to get it? No. Why? Because see, if I have to assume an exponential function, we'll be assuming it with two unknown. The base is unknown, and we can have something as product also, bacho. Okay, with the variable of the function. So we are given only one value. Phi of 2 is 2. We can't get it. But then see, since the question needs phi 4 and phi 6, what we can do is replace x and y both by 2. So it's phi 2 whole square. So phi of 4 is nothing but 4. Similarly, phi of 6 will be 4 plus 2 is phi of 4 into phi of 2. So it's 8, and that's it. Okay, so that was again a purpose. So two things. Looking at the relation, we know it. But can we find it here? No. Then I went back and tried to find this value with this thing, because we need 2, 4, 6, there it's multiple only, so we got it. Okay, so that's why I shared this question without realizing, see, that we don't need it because lambda, mu, delta, they are all one, so any power doesn't matter here. So that's it. Next question is this given equation, 0. If given equation represents 3 lines forming a triangle ABC, then find centroid of triangle ABC. So let's write the equation. So see, whenever I get something in this form, a polynomial form, whether it's a complex number, anywhere in algebra, the first thing I try is, even in like any equation which can be transformed to a polynomial form. It might be in trigonometry, it might be in algebra, anywhere, doesn't matter. The first step I try is to factorize. So that's what I tried here. So I took x square common, y plus 2 minus y square common, y plus 2, and this is equal to 0. So you got 3 factors. So every factor is a linear factor. So these are 3 lines. Isn't that, bacho? So what are those 3 lines? So x is equal to y, x plus y equal to 0, and y is equal to 2. So if you draw it, x is equal to y, x is equal to minus y is equal to 2, and that's it. So what we need is centroid. So it's simple, isn't that? So it's 2 comma 2, it's minus 2 comma 2, and this is 0 comma 0, centroid. You can easily find it. Okay, so now moving to the next question. Given determinant of AB is not equal to 0, A and B are 3 cross 3 matrices such that determinant of A, we are given determinant of A is 3, determinant of B is minus 2, then determinant of adjoint of AB into adjoint of AB inverse determinant. See, this is one question which I will say I just frame it looking at the trend of the questions. Okay, so I just try to use something else using inverse within adjoint and so those things. Okay, so first property will be using it that determinant gets distributed over what? Determinant gets distributed over the product. So we can write it as this into determinant of adjoint of AB inverse. Okay, now again, 2 properties. Determinant of P times A is P raised power n determinant A, assuming A is n cross n matrix. And similarly, determinant of adjoint of A is nothing but determinant of A n raised power, determinant of A raised power n minus 1. So determinant of adjoint of AB. I think that's the first determinant. Yeah. So let me write it here only. So it's nothing but if I take it as matrix C, so it's determinant of adjoint of C, so it's determinant of C raised to the power 2. So if I just concentrate on the first part only, so it's determinant of adjoint of AB raised to the power 2, so it's nothing but AB raised to the power 4 here. Now again it gets distributed, so A raised power 4, B raised power 4, so 3 raised power 4 into 2 raised power 4. So that's your first part. Now moving to the next part, which is determinant of adjoint of AB whole inverse. So again, what is it? So it's nothing but AB inverse whole square. So whatever matrix you have, so adjoint of C, determinant of adjoint of C is determinant of C whole square. Now, so we know this is B inverse into A inverse using property of inverse. And then using property of determinant, which says it gets distributed. So B inverse determinant whole square, A inverse determinant whole square. And again, now using the one more property, determinant of B inverse is nothing but 1 by determinant of B. So this is nothing but 1 by 3 square into 1 by 2 square. So the answer is nothing but 3 square, 2 square get cancelled. So 3 into 2, 6 square is 36. So that should be the answer. So that's one question which I just framed looking at the trend here. So bit of difference, I mean not the routine one, that determinant of adjoint of 3 times, adjoint of 2 times, say whatever, that you have sufficient such type of question as previous year. Now this is one more question which I framed to discuss with you people the importance of characteristic equation, Cayley-Hamilton theorem. See, that's the matrix here. So if you are given any matrix and the order of the matrix and the polynomial relation related to that matrix. Okay, if the order of the matrix and the degree of polynomial match, then the first step should be you will start with a minus lambda I, determinant equal to 0. We call it characteristic equation of a square matrix. Characteristic equation of a square matrix. So just do it. So it's like 1 minus lambda 0 2 0, 2 minus lambda 1 2 0, 3 minus lambda, determinant equal to 0. So if we solve it, so it's 1 minus lambda into 2 minus lambda into 3 minus lambda. I'm just opening it, okay, about first row. 0 into anything is 0, plus 2 into, so it's rather minus 2 into 2 into 2 minus lambda is equal to 0. So now let's simplify it. So this is minus lambda cube. Then how much will that be? So okay, just a minute. Acha, lambda square. So if we go for lambda square, so it's 6 plus 6 lambda square, and then for lambda it will be 3 2 6 2 9 11. So it's minus 11 lambda, and then 1 2 3 6, okay, plus 6. Now rest is minus 4 minus 8 plus 4 lambda, right? Minus 8 plus 4 lambda equal to 0. Now that's our characteristic equation. Now see Cayley-Hamilton theorem. It says that any square matrix satisfy its characteristic equation. So first let's write it in the perfect form. So minus 6 lambda square, and then you take it that side, so plus 7 lambda, and then plus 2 equal to 0. So what did I tell you right now? I said that Cayley-Hamilton theorem says that any square matrix satisfy its characteristic equation. So you replace lambda by the matrix A itself. So a cube minus 6a square plus 7a, and then here 2 times, of course, instead of 1 you will put the identity matrix I, and this is null matrix. So now compare it with the given relation here. So these two terms match, so that means P is nothing but 7 and Q is nothing but 2. So P is 7 and Q is 2, and then you get it, bachon. So that's how we use characteristic equation of any square matrix. So that was the purpose of this question. Now moving to the next one, fx be a differentiable function such that that's the relation. Okay, so again I just thought to frame a question based on functional relation to use it in an integration. Okay, normally we use it for differentiation or to get the function. Here the purpose of framing this question was to use it here. So then the value of 1 to 7 fx dx is. So what I actually kept in my mind while framing this question was Bahubali property. If you use Bahubali property here, so it will be f of 8 minus x dx, and then see, use that relation bachon, x minus y. So f of 8 minus f of x here, of course, and plus 8x, and that's it. And f of 8 is how much? It's 8. So 8 into 7 minus 1 is 6, 48, and plus 8 into x square by 2, 1 to 7, and then minus fx, take it this side, and this is 2i. So you get i from here, and that's what we need here. Okay, so the intention behind writing or framing this question was to use functional relation in integration. Okay, so that's it. Now moving to the next question. Next is that's again a question framed keeping in mind the use of Bahubali property in summation. Okay, so again see, s is equal to 0, r goes from 0 to 100. See, these questions might really be important, bachon, for keeping in trend and keeping in mind the level of the question I'm expecting in the upcoming shift. So I just frame these questions. Okay, so r square into, not all, I mean when I'm saying that I framed this question, only those questions. Okay, now see, again if I use Bahubali property here, so s is summation. I already told you how to use it. Upper limit plus lower limit, 100 plus 0 is 100 minus r. Replace r by minus 100 minus r. So these two terms will interchange, isn't that? So sine of 100 minus r minus sine of r, and then this is actually r into 100 minus r. So this will be 100 minus r, so cos of 100 minus r into r, so that remains same. And here also this is nothing but of course that's form you had, so you again have the same thing, but there's no change. So, but numerator the sign got reversed. So when you add them, you get it as 2s is equal to 0. So hence the sum should be 0 without any calculation. So that again might be a really important question, really important concept to keep in your mind. Now the next one is point. This is point. P123 is rotated about its foot of perpendicular on the line, drawn on the line, foot of perpendicular. So that's the line which is x minus 2, so passing through 2 comma 0 comma 1, whose DRs are 1 comma minus 1 comma 1, isn't that? Now there's a point P which is 1 comma 2 comma 3. See the question again, I will say that I framed this question keeping in mind the type of question which can be framed. See, I have already uploaded the expected most anticipated questions of 3D geometry, and they have already asked. See, I mean, I'm not saying that I have anticipated that it is there. There are not many choice you have. When you remove the plane part from the course of 3D geometry, you are not left with so many choices to frame the question. Okay, so if you have time, if you wish, you can go through those questions once more based on shortest distance and different types. So one more question I try to frame here, a bit different looking question but a simple one. Okay, so the question is a point is rotated about the foot of perpendicular drawn from this point on the line by an angle 90 degree. So rotated by an angle 90 degree, you come to the point Q, join P and Q, and what are we given to get? If area of this is A, then you have to find 6A. Okay, so you have to find the area only. Now see, if you rotate it by 90 degrees, so isn't triangle PMQ is a right angle triangle? Of course. And right angled at M only. And since you are rotating it, so it's a right angled isosceles triangle. So therefore, so the scenario is something like this. So area is how much? So area is half base into height. So PM whole square. So the question zeroes down to finding the perpendicular distance of this point from this line. That's it. Okay, and now we have method. Okay, I've already discussed it in that video, that expected questions from 3D geometry. So you can find this distance. How much is it? So 1 plus 4 5 plus 4 9. Okay, good. So that's 3 if I'm not wrong. And then you can find drs of this line, so which is x2 minus x1, so 1 minus 2 minus 2, and then you can find this angle. So PM is nothing but 3 sine theta bachcho. And how will you find this angle? You will find this angle using cos theta is a1 a2 plus b1 b2 plus c1 c2 divided by under root of a1 square plus b1 square plus c1 square into under root of a2 square plus b2 square plus c2 square. So that's it. So now moving to the next question here. Okay, that's it. So those were the questions. There are few more questions. Just a minute. If you give me a time, some time, let me just quickly check it, bachcho. I just got added few more questions. I think I forgot to share it here. Just a minute, bachcho. Wait for a few minutes. I will get it done here itself in front of you people. I will just I need to check out that file. So those were the actually questions which with which I started. Then I thought to add a few more questions. I think I sent that file. Just a minute, give me some time. Okay, so meanwhile you can go through the questions and solve it, and yeah. So I am done with this. Okay, so moving to the file again. I hope I get it. Yeah. So just a minute. So I named it as actually the question. So I marked this file as paper as tough test. Why? Because see, my expectation is near the end of the session, this session we'll be having the questions. Yeah, these are the questions which I got added up in the later half. So after it, okay, just a minute. So we are done with this one. Now, so that was the last question. Now moving to this one. Yeah, just a minute. Yeah. So moving to this question, it is the z1 is 1 plus 3 iota, z2 is 3 plus iota, question of complex number, and p is greater than 0, then minimum of this value. Okay, so what do we need? We need minimum of mod of z1 minus p plus mod of z2 minus p. From our basic understanding of geometry of complex number, we know that this is distance between z1 and p. This is distance between point z1 and p. P is a real number, is greater than 0. So you have inequality, that means the number has to be a real number. And then this is again distance between z2 and p. So when this sum of the distance can be minimum, so if I go with this thing, so one point is 1 comma 3, so this is, let's say, z1, another one is 3 comma 1, let's say this is z2, so that's your z1 z2 joining this, and but p is somewhere on the real axis, so that's our real axis. On the organ plane, this is our imaginary axis. What do we need? We need minimum value of the sum of these two distances. Isn't that? Okay, now see, whenever you come across such a situation, what do we do? Okay, what I will suggest here is, rather using any like application of derivative or maximize, minimize, nothing, just take mirror image of z2 on this line on which your p lie. Okay, so mirror image, so I call it as z2 dash. Since it is an mirror image, so p z2, if I and this one are equal, they are mirror images, isn't that? On this mirror on which your p lies, so these are equal. So that means, so minimum of z1 minus p plus mod of z2 minus p is same as minimum of, so if you are looking for minimum of this, so it's same as looking of for minimum of z1 minus p plus mod of z2 dash minus p. I think all of you will agree because they are same, isn't that? These two are same. Now we are done. Why? Because see, join it. Now using triangle inequality, we know sum of two sides is always greater than equal to the third side. So minimum value will be equal to the third side because it's always greater than equal to the third side. So the minimum of mod of z1 minus p plus mod of z2 minus p or z2 dash minus p is same, is equal to distance between z1 minus z2 dash. That's it. And when will that happen? That will happen, see, triangle inequality gets converted to equality when all the 3 points get collinear. That's it. So p should be here, bachcho. And how will you get it? So the mirror image, so this is 3 comma 1, it's 3 comma minus 1. Just write equation of line joining z1 and z2 dash using 2-point form here. Okay, so y minus y1 is equal to y2 minus y1 minus 4 upon x2 minus x1 is 2, and then x minus 1, and that's it. And put y equal to 0 for p. Okay, so that's our required p. So y is 0, so it's minus 2, so 3 by 2 is equal to x minus 1, so x is 5 by 2. So p should be 5 by 2. Is that an option? That's an option. Okay, so that was a question. Again, I will say I framed it. I mean, just to discuss with you some aspect of geometry related to complex number on the organ plane. Now that's really a good one. Based on series, r goes from 1 to n, and that's r is power 4 plus r square plus 1 upon r is power 4 plus r. It is given to be 675 by 26. See, I didn't solve it completely. I got it as a doubt. I didn't solve it completely. But then when you get, there's a power cut. Okay. I'm sorry, you can't see me, but then I'm not going to discontinue with it. I'm just see, you can still see the board, bachcho, isn't that? So I will continue. You can see the board and then you can look at the question, the way I'm approaching it. So what I will do here is, see, I wrote r is power 4 plus r. Okay. And then added r, subtracted r here. Now that's it, that's done, isn't that? So this is nothing but summation of 1 when r goes from 1 to n, so this is n. Plus, now this is summation of, now look at it carefully. So r into r cube plus 1. Now r cube plus 1, a cube plus b cube, a plus b, and a square minus ab plus 1 these terms get cancelled. So the second one is, so this is n plus summation of 1 upon r into r plus 1, and we all know how to tackle it. We just write it as a difference of these two terms, and then r goes from 1 to n. Start putting value of r here. Now I think we have done such type of question. So r is 1, then it's 1 by 2 minus 1 by 3 plus dot dot dot, and the last one is 1 by n minus 1 by n plus 1. See, the pattern is clear. If you are left with first term initially, okay, then we are left with the last term at the last and with opposite sign. So we are just left with n plus 1 minus, see, it was good, I didn't discontinue here, okay. So that there was a lag of just few minutes here. So that's it. So I found it to be a good question, okay, so that's why I shared with you people. Now again, next one, x raised power 16 in this expansion. So 1 minus x into 1 minus 5x into 1 minus 5 square x, 1 minus 5 cube x, how many terms? 1 minus 5 raised power 16x. How many bracket do we have? How many bracket we have? So we're starting with 5 raised power 0. So 0 to 16 we have 17 bracket. We need coefficient of x raised power 16. What does that mean? That means from 16 bracket we'll be picking up x wala term with x, and from one bracket we'll be selecting 1. Okay, so how can we do it? If I select x from here, okay, so x raised power 16. See, try to understand, bachon. Then see, if I'm repeating, if I select this one and 1 from here, from the first bracket, 1 from rest of the bracket, x, so it's 5 into 5 square into 5 cube dot 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 5 raised power 16. Plus times, why? Because negative or even times negative makes it positive. Similarly, if I choose 1 from here and from the remaining bracket x, so now 1 by 1, right, so not from here, so it will be 5 raised power 0 into 5 square into 5 cube dot 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 5 raised power 16. Achha, what you can observe is 5 raised power 0 into 5 raised power 1 power of 5 will be missing in every term. 1 power of 5 will be missing in every term. From 0 till 16, 1 power of 5 will be missing, bachcho. Okay, so at last I'll be selecting 1 from here, and from rest of the bracket the terms with x. Okay, now how can we solve it is the crux of this question. So we have this series, and how can we solve it? Okay, so if I say that divide and multiply the entire series by 5 into 5 square into 5 cube dot 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 5 raised power 16. Okay, so divide and multiply by 5, 1 plus 2 plus 3, 16. Divide. When you divide it here, so you write it the same one. See what will happen is, so this is the, okay, sum of natural numbers in the numerator, power of 5, so it is n into n plus 1, 16 into 17 by 2. We need coefficient here, okay, into, see, this is 1 plus, isn't this 1 by 5, right? Isn't this 1 by 5 square, and the last one is 1 by 5 raised power 16, and what did we get? We got a GP whose common ratio is 1 by 5, number of terms are 17, and then use it, compare it, and you have the answer. Moving to the next question. So that again is an important good question. See, whenever we have to solve a series, I always suggest to write the general term. Now the general term here is r square minus r plus 1 into r factorial. Okay, that you all can easily see here, bachcho. Isn't that? Now again the point is factorial. How can you solve this series? Okay, so now many of you can say, where is this in the course? There's nothing great about this series. The only thing is to break it as a difference of two series. Okay, so let's try. So what I see, I have actually done it, but then again the point is, will I be able to recall it? Let's see. So what I tried actually, wait, I won't write it, so I'll be writing just the general term here. Okay, so r square, So if I write it as r plus 1 square into r factorial. Okay, so r square plus 1 means I need plus 2r minus 3r. No, I don't think that will help. Wait, just give me a minute. I solved it 2 days back itself. I got it as a doubt. I solved it. There was a bit of manipulation. Okay, so it happens at times that I may miss it, but then I believe I will be able to get it. R into r plus 1. Wait. Okay, r square plus r into r factorial. ठीक है, r will be common, r plus 1, right? So then I have added r, I need to subtract r. Okay, so minus 2r into r factorial plus r factorial. Okay, so I wrote it as r into r plus 1 into r factorial minus. Then what I did was r minus 1 here into r factorial. Okay, see, the point was actually when you do it, so you get it as r into r plus 1 factorial. Bachcho, isn't that? So it's next term succeeding or preceding. So I'm going towards preceding term. So isn't that is preceding term? R ki jagah replace r by r minus 1, you get this term. Okay. So now when I wrote it, so I used 1 r here and plus 1. So I'm left with minus r here. So it's minus r into r factorial and then plus 1. Okay, plus r factorial. So that we have already used. Now I can write this as minus r plus 1 minus 1 into r factorial. Okay, so therefore your general term is r into r plus 1 factorial minus r minus 1 into r factorial. That's one, the difference of two consecutive terms. Okay, now moving to the next one, so which is this one. So if I remove bracket here, so it's minus times r plus 1 into r factorial minus 1 into r factorial, and we are done. Yeah, that's it. So this is difference of two consecutive terms here, minus this is again difference of two consecutive terms. That's it. Now use summation. R goes from 1 to whatever. Alternate terms will get cancelled and you will have the answer. So that's it. That's it for today. Okay. So those were the questions I wish to discuss with you. So I believe the concepts, the type of questions I shared here, I wish that they help you in your upcoming test. So that's my assumption, the level of question which I am expecting in the upcoming shift here, bachcho. Okay, so with all the best wishes for those students who are going to appear on 28th and 29th of January taking the shift, with all the best wishes from our entire team here, bachcho. May God bless you all.